there's a problem titled Limits at Infinity and Rational Functions. Find the following limits. If necessary, select the most informative answer from positive infinity, negative infinity, and does not exist. You also could have a rational number like 3 over 5 or 2 over 3. It could be 0, okay? So let's go through a couple of things first before I go through the complete example. So first of all, you kind of need to understand how to read this. What does it mean? So when it's saying the limit, this says find the limit when x is goes to a positive infinity. So I always think, hey, I'm looking what's happening to this value here when x is getting bigger and bigger and bigger. Okay? And so in part B, it says find the limit as x gets closer to a negative infinity. So what's happening as x becomes a bigger and bigger negative number? Okay? So to do these problems, the first thing they ask you to do is to divide both the numerator and the denominator by the highest power of x in the denominator. So in part A, I look at the denominator, and my highest power of x is x in the denominator. So I would divide everything in the numerator by x and everything in the denominator by x, and then kind of look at the problem. And then for part B, I look at the denominator. The biggest power of x is x to the third. So again, I would divide everything in the numerator by x to the third and everything in the denominator by x to the third. So I will show you what that looks like and then how to look at each problem. But before we go any further, I kind of want to explain what this stuff down here means. It says, then use the following theorem. Okay, for any positive integer n and any real number a, the limit of x as it gets bigger, right, x as it goes to a positive infinity, of a over x to the n equals 0. And it doesn't matter if it goes towards positive infinity or negative infinity, it equals 0. Okay? Let me kind of show you what that means and where that comes from so you have a better understanding and it's easier to remember. Okay? So, let's look at this. So, if a was 3 and n was 1, then we have 3 over x. Okay? So what is happening to this value 3 over x is x gets bigger, right? Gets closer to a positive infinity, right? Get bigger and bigger. So I just want you to think of a few values here, right? So 3 over 10, right? We know that's 0.3, right? 3 over 1,000, 0.003, right? So what's happening, and I'm just picking these numbers, but they could be any number. You can see what's happening is x gets bigger, this value gets smaller and smaller and smaller and closer to what value? It's getting closer and closer to 0. Okay? And that's what this identity is saying. Okay? And look at this value here, right? Same with this number here. As x is getting becoming bigger negatives, right? What's happening to this number? So 5 over, again, we could say, 10 to the third compared to 5 over 100 to the, would be a negative 10, right? Because we're talking about getting smaller, or not, well, bigger negatives, right? What's happening to this? Okay? It'd be a negative 0.005, right? And then it's just going to be getting to be a smaller and smaller number, closer and closer to 0. Okay? So that's what this part represents. So let's actually look at a couple of examples. Okay, so in the example that we have here, the first thing we do, remember, is to divide both the numerator and denominator by the smallest power of x in the denominator. So in this case it was x, so remember we're going to take a negative 6 over x minus 5x squared over x. We're going to simplify that. We're going to do the same thing to the denominator. Okay, and so that's going to get us negative 6 over x minus 7x, okay, over a negative 3 over x minus 5. Now what's happening here? As x gets bigger, negative 6 over x we know will become closer to 0, okay? And as x becomes a bigger and bigger number here, negative 7 times that value is going to become a bigger and bigger negative number, right? Because it's multiplied, it would be multiplied by a negative 7 basically. So that's getting closer and closer to a negative infinity. And then we look at the denominator part. We do the same thing, okay? Negative 3 over x gets as x gets bigger will become closer and closer to 0. And 0 minus 5 is, that would be close to a negative 5. So if I have a really large negative number and I divide it by a negative 5, what's happening to that? It's getting closer and closer to a positive infinity, right? So if I take a bigger number and divide it by a negative 5, it's going to give me a bigger positive number. Okay, think about that. Okay, and so the limit as x approaches positive infinity of this value is a positive infinity. Okay, so let's look at another example here. So on this one, the biggest power of x in the denominator is x to the third. So we're going to divide everything here by x to the third. Minus 2x squared over x to the third over 5 over x to the third minus 7x to the third over x to the third. Okay, and so let's simplify that. So we have 7 over x to the third minus 2 over x over, let's see, 5 over x to the third minus 7. So what's happening here? As x gets bigger and bigger, we know from the identities from that 7 over x to the third is going to be close to 0, right? So we're going to say the limit of that is 0 and minus 2 over x, 0. So 0 minus 0, that numerator would be 0. So in the denominator here, 5 over x to the third, that value will get close to 0, and so 0 minus 7 would give us negative 7. 0 divided by negative 7, that gives us, is going to simplify to 0. So the limit of x as it approaches a negative infinity, sorry, and I should have considered negative values here, but it wouldn't matter, right, because those are all zeros, of this value is 0. Okay, so as closer, the bigger the negative value we pick, the closer and closer it gets to 0. That's what the limit is. Okay, so let's look at a couple other examples. Okay, so in this one, part A, we need to look in our denominator. The biggest power of x is x, so we're going to divide everything by x. So 5x over x minus 4 over x over 2x over x minus 5 over x. And that's going to give us 5 minus 4 over x over 2 minus 5 over x. Now what's happening as x gets closer and closer to a negative value, right? Well, it doesn't matter whether it was positive or negative, 4 over x will get closer and closer to 0, right? We know that. So this will get closer and closer to 5. 5 minus 0 is 5, right? And same with the denominator. 2 minus, this value gets closer and closer to 0. So this will be 5 over halves. 5 over 2. So the limit as x gets closer to a negative infinity of this value is 5 over 2. Okay, so let's do the same thing for part B. So we're going to divide everything by the highest power of x in the denominator, so that's going to be x. So I'm just going to do this one a little bit faster. So if I divide this by x, I get 5x minus 4 over x. And then I take the denominator, divide that by x, and that's going to give me 5 plus x over 7 7 over x, sorry. I wrote it right, said it wrong. Okay, so what's happening here? Okay, as x is getting bigger and bigger, 5 over x is going to be getting bigger, right? And minus 0. So this top part would be a positive infinity. And then the bottom part here, x over 7 will get closer and closer to 0, so we get 5 plus 0 is 5. So if we took a very large number and divide it by 5, if we pick a bigger number and divide it by 5, it's just going to be getting bigger and bigger as well, right? So the limit as x approaches a positive infinity for this value is a positive infinity.